Hello, this is a video of our first practice problem in the notes. It starts on page 3 of the PDF. And it is the hyperbola with the equation x squared over 4 minus y squared over 9 equals 1. The slide in the notes, the words at the top say we're going to graph these using a magical rectangle. When we graph these, you're going to first identify the center, then we're going to draw the rectangle, then we're going to draw the asymptotes, then we're going to draw the hyperbola, and then we're going to fill in all this information. But the orders, that's the best order to do it in, I think. So first step was to identify the center. And I told you guys, and I will stick to it, that the only ones I'm going to ask you to graph will have the center at the origin. That's clear because x has nothing subtracted from it or added, same with y. So the center is going to be 0, 0 for all of these. It's like a free point. You're welcome. Center 0, 0. You can write that right here. All right. The next thing I'm going to want to do is I'm going to want to identify A, B. I might as well do C as long as I'm doing that, because that's the A and the B are going to help me draw the rectangle. So with hyperbolas, the number underneath the positive, the number in the denominator of the positive term is always going to be A. In this case, that's 4. Sorry. A squared is the denominator of the positive term, and that's 4. B squared is the denominator of the negative term, and that's 9. So I can say A squared is 4, B squared is 9. This means that A is 2, and that B is 3, because that's how math works. Like I said, as long as I'm doing this, I might as well go ahead and find C. In our previous videos, we saw that C is A squared plus B squared, which is 9 plus 4, which is 13. Therefore, C is the square root of 13. It's not my favorite number to square root of 13, but it's a fine number. It is between 3 and 4, so bigger than 3 but smaller than 4. I know that because 13 is bigger than 9 but smaller than 16, and therefore, 13 is between 9 and 16, and therefore 3 is less than root 13, which is less than 4. That's how square roots work. Whatever number I square to get 13 has to be bigger than 3 and smaller than 4. So I got my A, I got my B, and I got my C. So step 1, find the center. Step 2, identify A, B, and C. Step 3, draw the rectangle. So that means I go A units, or whatever's underneath x squared, I go that many units in the x direction. So I'm going to go 2 units to the left. Call that 2. 2 units to the right. And then how far do I go in the y direction? Well, look at the number underneath y squared. In this case, it's 9. The square root of that is 3. So I'm going to go up 3 and down 3. So number underneath x squared was 2 squared, so I went 2 each direction x. Number underneath y squared is 3 squared, so I went 3 up and 3 down. Now I draw myself a rectangle. Again, I always do it dotted, so I remember it's not actually part of the hyperbola. I have my rectangle. Yay! Rectangle is done. Step 1, find the center. Step 2, identify A, B, and C. Step 3, draw the rectangle. Step 4, draw the asymptotes. The asymptotes are going to go through the diagonals of this box I just drew. So they're going to look like that. They're going to look like that. Nice, almost there. One One thing you might want to realize is we haven't drawn any part of the hyperbola yet. We've done all this work, and so far we had zero, well, not 0 points, but we don't have any actual curve from it. Find the center, check. Identify A, B, and C, check. Draw the rectangle, check. Draw the asymptotes, check. And now I'm gonna draw the hyperbola and then plot the foci, but it doesn't matter what order you do that in really. And sometimes it's helpful to draw the hyperbola first. So start, because this is a side-to-side one, I know it's gonna be like in here somewhere. So I start at the vertex, I go here, I go there, I go here, I go there. Notice I use like a solid line for these because so far this is the actual hyperbola. Everything else we've drawn is just reference. And now, this is why I think it's good to draw the hyperbola before you do the foci, because now it's easier to see that the foci are going to be here and here somewhere. And it may not be right there, but I know they're going to be somewhere in that area. So maybe I shouldn't draw them yet. So now I'm going to move, to find the foci, I'm going to move C units along the transverse axis, which means C units to the left and C units to the right for this problem. So we said C was root 13, which we realized was between 3 and 4. So I go 1, 2, 3, 4, somewhere in here. You might be like, is it closer to 3 or 4? I don't care. Just put it in between 3 or 4. Put it halfway. That's one of the foci. I went over this distance, root 13, from the center. 1, 2, 3, and a little bit. I'm going to do the same thing to the right. 1, 2, 3, and a little bit. So these are my two foci. This point here is a vertex because it's on the hyperbola, and this point here is a vertex because it's on the hyperbola. These points don't really have useful names or use at all, so we're not going to worry about them. In ellipses, we call them like co-vertices or something, but you don't have to worry about that with hyperbolas. So now you can just fill in the information here and we'll be done. The vertices are -2, 0 and +2, 0. I'm going to write it as one pair with a plus or minus in front of the 2. The foci, I went this far to the left, this far to the left, and that far was this distance. It was root 13. A number bigger than 3 but smaller than 4. So I'm just going to call it plus or minus root 13, 0. Again, minus root 13, plus root 13. Now the asymptotes, we talked about this in the first video, how to find them. Just to remember, these are always going to be of the form y equals mx, because our b, the y-intercept for all these, is always going to be 0, because I'm only making you do them centered at the origin. And the question then is, what is the slope of each one of these lines? And the easy way to find it is to just read it off the graph. I go up 1, 2, 3 units, and over 1, 2 units. That's how I get to this point right here at the corner. So that's 3 over 2. Rise over run. 3 over 2. Oops, don't need parentheses for this one. Rise is 3, run is 2. You may be able to look and see, well, this is really just B over A. Is that going to be true every time? It's going to be true as long as this is one that opens left and right. There's one that opens up and down, which is going to be the next video. It might be a little different, but again, I recommend you just read it off the graph. The other one, this one, has a negative slope, and it's down 3 and over 2. So that's just going to be -3 halves. So I can do it like this. Plus or minus 3 halves x. So now I found the 4 things I wanted to find: center, vertices, foci, and asymptotes. The next example is one with that opens up and down as a vertical transverse axis. So you'll see that it's very similar with some very minor changes.